be okay, good morning. Today we are unit on Introduction to Graphing and Linear Function, and lesson 5, finding the intercepts of a linear function. Basically, we'll be finding the x and y intercepts of a straight line, and our goals for this specific lesson is to determine the x and y intercepts of a linear function. Then we'll be solving problems involving x and y intercepts of a linear function. And thirdly, to recognize the limitations of the x values and y values in contextual problems. But for today's lesson, we'll be focusing on the first goal, to determine the x and y intercepts of a linear function. You will need your graphing calculator if that's what you'll be using. So I'll zoom out a little bit here so you can see. So you'll need a graphing calculator, or if you're using Desmos, your phone or your computer. So you need these two technology. And to help you with your graphing calculator, you will want to have your calculator instructions for Applied Math 30S handy beside you. Or if you're using the Desmos, you want to have this handout with you here. By now, most of you memorize the steps, but just in case you forget the procedures, there are 2 sides to it. So as we met, we've been continuing our whole on this, the entire booklet is focusing on the graphing and linear functions. And we said a linear function is basically a straight line, another way of describing a straight line. But more specifically, it's a straight line that has, could be an x-intercept, a y-intercept, could be no intercept, in the sense that there's no x and y intercept together. There might be just one intercept. So we look at all of those today, and then we look at some questions related to it. Now, the x and y intercepts, let's see here. The x-intercept is where the graph of an equation crosses the x-axis. So looking at, this would be your x-intercepts here. So it's your coordinated plane, x and y axes. The y-intercept is where the graph of the equation crosses the y-axis. Okay. First, I'll show you how to find the intercepts using your graphing calculator or Desmos. And then we will look at the algebraic way or the non-technology way of solving it. Let's go back to your classroom booklet. So the x and y intercepts are 2 special points on the graph of any function. The y-intercept is where the equation crosses the y-axis. And the x-intercept is where the graph crosses the x-axis. So here is the x-axis here. So your y-axis, where this is your Cartesian plane. So it crosses the y-axis at the point 4. So that's referred to the y-intercept. The coordinates for this particular point here would be x is 0 and y is 4. So when we are referring to the y-intercept, we're basically saying find a value for 0 and the value find the value for x, which is 0 here, and the x value, the y value is your y-intercept. So where anywhere on the y-axis referred to as your y-intercept. Your x-intercept now refers to the point on the x-axis, your x-axis, that the line crosses. Here it crosses at -8, so your x-intercept is -8. At this point, y is 0, so your coordinate here would be -8, 0. Keep this in mind because part of this lesson, I'll show you how we can determine these x and y intercepts without a calculator. Let's look at some illustration of x and y intercepts. Here we have example 1 here. This is your y-intercept. And your y-intercept in this case here, y-intercept, is, in this case, is 6. So the coordinates for this point here would be 0, 6. X is 0, y is 6. The x-intercept, which is this point here, we have is 1, 2, 3. X-intercept is 3. The coordinates here would be 3, x is 3, y is 0. Okay. Now, someone might ask, just the previous lesson, we looked at the slope of this line. And this slope here would be a negative slope. So we have a negative slope here. Here we have a negative slope. So we guess slope is negative. And the reason it's negative, because as we go from after increasing x value, as x increases here, the y decreases. So we say slope is negative because it's going downwards. Really. As x increases, y decreases. So it's negative because as x increases, y decreases, or the y values, or the y coordinates, y values decreases. So we can say y values decrease. So we have a decreasing, so we say that's negative. If you look at our first graph, let me go back to the first one here. As you go from negative to positive on the x-axis, the y increases. So we say this is a positive slope. It says x increases. So the x values increases, right? So we can say the x value y values increase. So we say that's positive. So we say the slope is positive because it's going upwards, so we can say it's upwards. while in a negative slope, it's going downwards. So upwards mean positive, downwards going negative. Or is it going from quadrant 3 to quadrant 1? So quadrant 3 quadrant 1, so positive slope. A negative slope will go from quadrant 2 to quadrant 4. Remember, your quadrants is listed from 1, 2, 3, 4. Let's review from the first lesson. So from this one graph, Cartesian plane here, we have our x-intercept at -8, where this line crosses the x-axis. And the coordinates at the x-intercept here is -8, 0, because x is always stated first and the y value second. And the y-intercept is 4, because the coordinate plane there, coordinates for that point is 0, 4. So let's highlight this here. And we also indicate this is the positive slope. This is going upwards, quadrant 3 to quadrant 1. And this is so we have the y-intercept here is so quadrant 2 to quadrant 4 means is negative. And x increases, y values decrease, we say negative. Let's look at the next graph. This line is horizontal. Notice it's horizontal and there is no x-intercept here. Right? But the y-intercept is 1, 2, 3. So the y-intercept is equal to 3. So this point here would be 0, 3 coordinates. And notice there is no x-intercept since the line does not pass 3 x-axis. Here we have no x-intercept. The only time when we'll have an intercept is if the horizontal line is exactly on the x-axis. Right. In this case, the equation, right, y is equal to 3. So that's the equation. Because the slope is 0. Generally, we write it like this: y is equal to something x plus your y-intercept. But since this in front of the x is 0, so we can write it as 0x plus 3. We can remove the 0x and we're left with 3. That's why we have y is equal to 3 as the equation. So there's no x-intercept because the line doesn't cross the x-axis, only a y-intercept. Now, this is when you're given a graph, and you're asked, hey, for you to find, you can look at it by visual inspection and discover your x and y intercepts. Now, what happens when you're given an equation? You're not given the graph, but you're given an equation and you ask yourself, okay, find the x-intercept and the y-intercept. Okay, so let's wrap it up. And the y-intercept refers to where the line crosses the y-axis. The x-intercept refers to where the graph crosses the x-intercept. Now, we'll go through your step-by-step procedure here. Sometimes your graph, okay, let me zoom out here. Okay, sometimes your graphing screen will automatically show the y-intercept when you press the trace key. At other times, you may need to enter the x values to 0, or press the trace, press 0 key, and press the enter key. Now, I'll show you step by step, and it's also in your booklet here. Here you're given an equation, and you want to find the x-intercept and the y-intercept. So the x-intercept, we'll find from here. From the way this equation is written, this would be your y-intercept. But I'll show you using your graphing calculator and Desmos how to determine it. Now, in your booklet, there's a step-by-step instruction on page 25, and I'll walk you through, or I'll go through this step of instruction, so you can find your x and y intercepts. Right. And you'll do a sketch of it. But let's look at this one here. Here you have y is equal to 2.32x minus 7.51. Now recall, in one of the previous lessons, we said that an equation of a line of a linear function can be written in this form: y equals mx plus b. And this is your slope, and your b is the y-intercept. So if you look at the way this is written here, this is your m value. So this would be like y is equal to mx plus b, right? So the m, your slope, is 2.31, and your y-intercept is 7.51. But you cannot determine the x-intercept by just inspection here. The y-intercept, the way it's written, yes, you can. This is your y-intercept. So we can see right away your y-intercept is equal to negative 7.51. Don't forget your sign in front of it. So using this form, we can determine the y-intercept. But how do we find the x-intercept? Later on, I'll show you how to find the x-intercept algebraically. But for this section, I'll show you how to find the x-intercept and the y-intercept, which we discovered here, the y-intercept. But we'll show you how to find the y-intercept and the x-intercept using your graphing calculator first, and then we'll use Desmos. Okay. So for now, you may not need your instruction sheet because it's already all laid out here. Okay, so I'll zoom out so you can see the full screen. So here we have your equation of y is equal to 2.32x minus 7.51. And we are now going to find the x-intercept and the y-intercept. Okay. So remember, your y-intercept, the value for the x is always 0. And for the x-intercept, the value of the the y coordinate point is 0. So we'll use that fact to determine the x and y intercepts. So first thing we do, we want to enter, just erase this here for now. We would like to enter into our calculator the entire equation. So I have my calculator on the screen. So I'm going to zoom out a little bit more so you can see the full calculator. So first step, step 1, press the y equal button. So we'll press the y equal button, which is right top here. Now I have something about in here I'm going to clear. So you should have everything in here as clear. You shouldn't have anything. So you want a blank screen, work on the blank screen. Enter the given equation in y1. So in line, enter the equation 2.32x minus 7.51. 2.32, and your x value is up here. Minus, now don't use the negative sign, use the minus sign there, 7.51. Okay, now line y equals 2, line 2, sorry, y2 is equal to 0. So we're going to put here y equal to 0. So essentially what we're doing, we're creating two lines. And where one of the line, y equals 0, that line will pass through the x-axis, a horizontal line. If you go back to this, here we have a graph. A horizontal line here is y is equal to 3. So we'll create another line here, y is equal to 0. So same as this here, here we have a straight line and we have another line here because we want to find the x-intercept using those two lines. So we'll find where they intersect. Now, y equals 0 is the equation on the x-axis, as I mentioned here, right? Now, they also indicate in the booklet here, you can highlight or make it bolder the line for the second equation, y equals 0. So use the arrow keys to move the cursor into the slash symbol in the front of the y to enter. Press enter. The slash symbol should make the line bolder and is blink. So this is optional, but it makes it easier for you to see the x-axis. The reason is because, now if I were to press graph here now, that's one line. Now, and here is your second line. Now, because this calculator has is color coordinated, you can see it easier. But if you have a TI-84 calculator where you don't see different colors for the line, this is helpful. But you can skip this step. This step here, this part here is optional. But I'll show you how to do it. I go back to my y, go to my y button, and I press my left arrow key here. That will take me back to where you see that in my case here. Now your calculator might look slightly different. Now I press enter and I go down and I want to make this a little bit bolder. So I'm going to press my right arrow key. There we go. And I press enter. And I press graph. And I'm going to press OK. It's flashing. Then I press graph now. That's my first equation. And the second y equals 0. Didn't make much difference in my graph, but if you're just using the one with no combination, it will make a difference. It'll look much bolder and brighter. And it says once you've done that, press graph like I did here. Now we need to find the x-intercept and the y-intercept. Now we know from algebra here, our y-intercept is negative 7.51. So let's find the y-intercept first, right? And then we'll find the x-intercept. Oh, your calculator will give it to you in your instructions here for you to find. Okay, let's go ahead and find the y-intercept. So the y-intercept is right down here. This is your step now to find your y-intercept. Press the second button and press trace button to access the calculate menu. So, okay, let's go that. First you press the second button. And then the trace button to access the calculate menu. And this is the calculate menu here. Okay. Now, what you would like to do here is to press enter, and the value for x is equal to 0. Enter. That's your y-intercept. Negative 7.51. So it's right there. Okay, this is a simple one. In your instructions here, they ask you to find the intersecting point here. It works, but the easiest one is to let x be 0 and solve for y. So let's do that again. Here's my graph to find my y-intercept. Second, trace, enter, let x be 0, y is negative 7.51. So your y-intercept now is negative 7.51. Doesn't matter which, what graph you have, decreasing or increasing. On the y-intercept, the x value is always 0. So that is why you can enter x equals 0 and you will find y here. Okay. Now we're going to go on to finding the Now we want to find the x-intercept, where it crosses the x-axis. I want to find where it crosses the x-axis here. Okay. Here's our graph. We have a graph. We press the second trace, and we'll access our calculate menu again. But we're not going to go to value here. We're going to go down to intersect. Because what you're doing now, here's your first line, y equals 3.2. Where's my equation here? Sorry, 2.32x minus 7.5. That's my, this is the equation here. But I also enter another equation, y equals 0, which is in this calculated is the red line. I want to find where these two lines meet or they intersect. That will give me my x-intercept. So by finding where these two lines intersect, you're actually finding the x-intercept. So to find where these two lines intersect, second trace and go down to intersect, number 5. Again, second trace. Here's your calculate menu, and you go down to number 5. I'm pressing the down arrow key, intersect. Press enter. Now I want to go off from there. I want to go off and press enter, press enter, press enter again 3 times, and you'll end up with the intersect. So my x-intercept is 3.23 or 7 or 2.234. And that's what you have here. Okay. By the way, you can use the same procedure to find the y-intercept. So you can do y trace and go to intersect. Well, in this case, you ask you the first curve, you may have to toggle down and go down to here. And then you press enter again. Now, that would still give us our x-intercept. Now that didn't work. So I wouldn't try that. So go back to find your y-intercept, say trace value, x equals 0. That's the quickest way, simplest way to use it. To find your x-intercept, second trace, intersect. Over to here, press enter 3 times. And there it is. Okay, so there you have it in terms of using your graphing calculator. Now, what happens if you have to use Desmos? Now, just a recap. This is also the same instruction finding your. You can write beside it on the flip side of this, how you determine the y value. This is also finding the y-intercept. Okay. And how do you determine the x values? This is finding your, yes, you guessed it, x-intercept. So for graphing calculator function, these are the two these are the different processes of finding your y-intercept and your x-intercept. Now let's go to Desmos. Now Desmos instruction will be a bit different. So I'll get my Desmos here and I'll zoom in a little bit. Now the instruction for Desmos are, in case we don't need, in this one here we have a graph, but here what you'll do in this case, we just have to enter my equation. Here I'm given the equation. So I enter the equation into the Desmos cell. Okay, I'm going to zoom in here. Okay, hopefully you can all see. Yeah, zoom it a little bit here. You can see the full screen. So here's my equations given, and I need to find the x and y-intercept. So here you have a blank screen. Make sure you have a new setting, nothing in it. You're going to enter your equation. So we start off with y. So your y here. Now, if you're using the computer interface, you may, let me just move a second here. You may see a different setting, but it will probably be more to your left here on the computer. So y is equal to, so equal button, 2.32x, 2.32x minus 7.51. Now your graph comes up automatically. Now, where you see these two arrow keys going down, if you press this, touch that, it will remove it. Now you have your graph. Now to find your x and y intercept, it's very much simpler. You touch where it crosses these two lines here, and that will give you your x-intercept. You touch here twice, and that will give you your y-intercept. So with Desmos, it's much more straightforward. You don't have to do many steps. Once you enter your equation, you find where on the x-axis the line crosses, find where it crosses the y-axis, and you tap on it twice. Now, if you're using a computer, you'll use a cursor and hover over, and it will show you your x-intercept. Notice y0 for your x-intercept. So your x-intercept is 3.237. Your y-intercept is negative 7.51, which is exactly what we talked about earlier. And if you look at our Desmos, our graphing calculator, it gives us the same result. Okay, 3.24, and we also have 3.24 here. So the x and y intercepts are much simpler on the Desmos compared to the graphing calculator. Okay, now we have a couple of other examples we'll walk you through. And these are all using the technology piece. Some of you are anxious to see the algebraic way, but I'll show you that as soon as we've finished. We'll do both at the same time. So here we have an equation given, and you're asked to find the x and the y-intercepts. Okay. So we'll use our graphing calculator, and then we'll do a sketch of this, a sketch of it at the end. So we'll go to our graphing calculator. Now, you can reset your calculator by, back up here. Now, you can reset your calculator so you wouldn't see any more of these other graphs, or you can simply go back to y equal button and clear. Now, to reset your calculator, as you know from the first instruction on your calculator instruction, press your second plus sign here, and you go down to the number 7, reset, all RAM, and 2 for reset. That clears it from any other values you may have had. It just gives you a clean slate to work from. Now find the x and y intercepts. So we follow the same procedure as we did before. First, step 1, we enter our equation. Now this is what you probably see on your screen. Let's go here. You want to quit. So you press your y equal button and enter the equation as it appears here. So let's do the first one. And by the way, don't forget you have to use the negative sign here, not the subtract sign of your computations. Leave that No. If I were to do that, let's say I put that there. We'll put, okay, it's 1 negative 5.2x and graph. You'll see an error. If that happens, it means you made a syntax error. You're not supposed to be adding this. You need to go to your negative sign. Okay, so we'll go to 2 back here, and we'll change that. Notice it's flashing. It tells me here, what you have there is wrong for the negative sign there instead. So negative 5.2x, I'm going to move over. So I'll repeat that, negative 5.2x plus 0.87 graph. Notice this will be a negative slope. This is going from quadrant 2 to quadrant 4. Now I want to zoom in a little more because it's hard to see my x-intercept here. So I can go to my zoom button and I can go to square or a decimal. That would give me a, well, that didn't work, actually zoom out. So I need to go to zoom and I want to go to decimal. So let's zoom in a little bit more. Now, if you want greater control, you can always go to your window and set your window to a different domain and a different range. But we leave it as it is right now. But if you wanted to see more detail, you can restrict your domain. So you can go from -2 to positive maybe 3. So we can do that to see what it looks like. So -2, positive 3. So I'll go x, y minimum -2, x maximum 3, and that will give me a bit more zoomed in here. Now, to find the x-intercept first, remember, we need to go back to a y equal button and let line y2 equal 0. And that's my y equal 0 line. So you want to find first the y-intercept here, this line. So we're going to put that here. So we let second trace y equals 0. This flashing here is 0.87. So let's write down the steps here. Okay. So step 1, y1 is equal to negative, I'll put a bracket beside that, 5.2x plus 0.87. And y2 equals 0. So we enter those two. Then we press graph. All right. So press graph. And we have a sketch of the graph here. One. So graph goes through. My x-axis, y-axis. Now we've discovered, now from here we can tell our x-intercept is 0.87, so I can write that here. This is where it's written. But let's find it on the graphing calculator. Second trace, let x be 0, y is 0.87. So first of all, we say the x-intercept or the y-intercept is equal to 0.87. The x-intercept, now we press second trace, I will go down, once you have a calculate menu, go down to intersect. Press enter. Now I want to move away from that y-intercept, but I'm going to go closely pressing the right arrow key, go down close to where you see the x-axis and the line meet. Then you press enter 3 times. 1, 2, 3. So flashing there, then you press the final one, and that will give you intersecting point 0.17. 0.17. Run to 2 decimal places. And there you have your x and y intercept. Now, using Desmos, we'll put on the arrow now. I'll clear that graph, and now enter your equation. Y equals negative 5.2. Notice there's no difference between negative signs here. Desmos recognize that it's a negative integer or a negative slope. And that's by the way, this tells me the slope is negative. This is the sign before the x value. Press x, then plus 0.87. Now that's my equation. I can toggle down. So now use your finger to pinch and to zoom in. You zoom in, tap 2 times, that's 0.87, is your y-intercept, and tap and 0.17 for your x-intercept. So that's how straightforward it is in terms of finding the x and y-intercept. Now, let's do another one. Here we have y is equal to 3.545x plus 7.5. I'll try the Desmos first. So first of all, you enter. So your y-intercept, you write that here. And x-intercept. From here, I can tell my y-intercept is 7.5. I'll write it here, but I'm going to prove it. But it's very difficult to tell my x-intercept from here, from the given graph. So let's go ahead and total up, clear that equation. Y equals 3.45x plus 7.5. Now notice if you don't see a graph, now if I go back here, if I were to press that sign there, that should give me my, wait a minute. So if you don't see a graph, try to pinch and with 2 fingers, your thumb and your another finger maybe, and that will, you can zoom in or you can zoom out. Once you have these, you tap on with the point where you see the x, so the y-axis meet the line. Tap it twice, so that's 7.5 your y-intercept, that's correct. Oh no, 7.5, that's right. And now tap on the point where the line meets the x-axis, negative 2.74. So we can write that down. So negative 2.17. Always leave your answer 2 decimal places. Using your calculator, it's a bit more longer process. I can go to my y equal button, clear the first one. Now, you don't need to clear the y equals 0 for your second line because you'll be using it again. So leave it there for now, because when you find an x and y intercept, but you enter y1 as 3.45x plus 7.5 and graph. Notice your graph is way on the other side of it, so you can press your zoom button. It's a shortcut, the zoom button. Okay, here. And I'll go to standard. The standard is zooming out. And there you can see your x and y intercept. And this is your line y equals 0. So let's find the y-intercept first. Second, trace, value, x equals 0, y is 7.5. This is what you have. Remember, x is 0, y, whenever x is 0, the value for y is your y-intercept. Now we need to find our x-intercept. And this is where you can, if you're forgetting the percept, finding x-intercepts, and finding the, x-intercept and finding the y-intercept. So I want to find my x-intercept. So second, trace, go down to intersect. I want to toggle down close to my x-intercept and press enter 3 times. And negative 2.17, which is exactly what we have in decimals. So let's do a sketch, right, of this graph. So we know it crosses the y-axis 7.5 and negative 2.17. So this is my that point. So y-intercept, and this is your x-intercept. So you may say, okay, Bishop, how do I go about doing this without the calculator? Now, so let's look at this first one here. Okay, to find the y-intercept, let x equals 0 and solve for y. So I take my equation. So I'm going to take my y equal equation here. So I'll take my equation. So I'm going to take this down here. Y is equal to negative 5.2x plus 0.87. So let x be 0 and solve for y. So I'll replace the value for x here with 0. So that'd be y is equal to, so here's my x value here. I'm going to replace that with 0. Now, if x is 0, 0 times negative 5.2 is 0. So we have y is equal to 0 plus 0.87. So y is equal to 0.87. So when x is 0, y is 0.87. So the intercept, so this is your y-intercept. Because x is 0, y is 0.87, which is what we also have here. Now, what if you want to find the y-intercept? Sorry, the x-intercept. Let's find the x-intercept now. Find x-intercept. Now here we let x be 0. In this case here, we let y be 0 and solve for x. So we say let y equals 0 and solve for x. Here we're solving for y. Now we're solving for x. So write down my equation. So maybe write my equation here. This would be my equations. Y is equal to negative 5.2x plus 0.87. So we let y be 0. So now this becomes 0. Negative 5.2x plus 0.87. So this will take a little bit more of work. So now I want to solve for x. So I'll move the x. We want to isolate the x. Right. So here we have negative 5.2x. I'll move it to the left by adding 5.2 to the right. So what I meant by that, here you have negative 5.2x. I want to get rid of this, so I add 5.2 on the other side. So this will give me 0. But since I added 5.2x on one side, and we'll do exactly that on the other side. So this becomes 5.2x. So I have 5.2x equals 0.87. Now x, now we're going to divide by, so we have 87 divided by 5.2. Now let's get our calculator out and let's see what that will look like. 0.87 divided by 5.2 equals x is equal to 0.17, which is exactly we got when we use a graphing calculator. So our answer is still the same. And that's your x-intercept. So if you're not too sure how to get this done using the algebra, I'll post this on the blog and the steps. And I'll do a few more examples of doing the algebraic way, but since this is applied math, we'll be using the technology mostly to find the x and y intercepts. So let's look at 2 more examples, and then I'll let you work on your questions. Okay, let's go on to graphing calculator again, and let's try this one here. Draw the graph of y is equal to 2.5x minus 14, label both intercepts. So we'll enter this into our calculator. So we'll do that diligently. Here, check it on. So my calculator, go to y equal button. Notice I will not change my y equals 0 here, but my y1, I want it, this is my y1 equation. So clear, mine becomes 2.5x minus 14 graph. Now notice, I'm not seeing my y-intercept here because my window, I'm too close to my window. I need to zoom out, come back out. So I can do that by going to my window setting and change it. I want it less, notice my y-intercept is negative 14. So I want y minimum should be far lower than negative 14. So I'll make that negative 20. Go down to y minimum, make that negative 20. Here you can see my x and y intercept. Now I'll go to the limit here and make this negative 14 here. Now, but I don't know my x-intercept. Somewhere between 5 and 6. Okay, but I don't know where it is. So I can actually do that here. I can do 1, 2, 3, 4, 5, 6. So somewhere here. I don't know where that specific value is. So I'm going to do a sketch here for now. So here will be my x-intercept. This is my y. I can now y-intercept. But we'll prove that using our calculator. Now let's go to our calculator here. Oh, so now first thing I'll do, I'll find my y-intercept. So second trace value, x be 0, y is negative 14. So this is correct. Now I need to find my x-intercept. Second trace, go down to intercept. Now make sure I'll move that cursor closer to the x-axis. I'm going to just go over it just for the fun of it and press enter 3 times. 1, 2, 3. And there is your x-intercept, 5.6. So this is actually 5.6. So x-intercept equals 5.6. You can go ahead and do it algebraically, but right now you want to stay with your graphing calculator. Now I'll go to my Desmos and do the same thing. I'll go here and clear my graph. Put y equals 2.5x. Y equals 2.5x minus 14. Okay, we zoom in. Here, pinch your finger, touch. Oh, there you have it. X-intercept 5.6, y-intercept negative 14. And we sketch and label it. I'll do the Desmos one first. I'll just switch between the two technologies. And here we have, oh, is it the same equation? Oh, it's a negative slope. Now, by the way, this is a positive slope. Notice it's going from quadrant 3 to quadrant 1. It's going up. Now they switch on us and said, hey, I'm giving you a negative slope here. So for Desmos, I'm not going to switch too much. All what I need to do is to go tap in front of the, and I press my negative sign. Now the graph, you see automatically switched. All right. Now I can go to a different line here and I can put here. Now, can I copy this? Allow me to copy it, but so y equals negative 2. I want positive, right? So equals, go back 2.5 x minus 14. Yeah, notice that's a mirror image, right? Of this graph here. Notice this is negative. It's going from your quadrant 2 to quadrant 4. And positive goes from quadrant 3 to quadrant 1. Now I'm going to hide the positive because I don't need that. But that's one way of the Desmos. You can actually find, you can still have your equation input, but you can hide it. So now I find my y-intercept and my x-intercept. So there you go. Your my x-intercept is negative 5.6. So we have 6 here and 5. So it's somewhere there. Negative, negative. 4, 3, 2, 1. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So negative 14. So this is my graph. Oops. Okay, let's go and do this properly. So we have negative 14. And this is negative. Continue my graph. Oops. Should choose a better line of this. So y-intercept and x-intercept. Negative 5.6. So we have tomorrow's class, we will go over how to use the algebraic method, but I want you to try finding the x and y-intercept using the algebraic way. Now, you already discovered it using your calculator. I would like you to repeat this process to find the x and y-intercept without the calculator. So let's recap. Our goal today was to determine the x and y-intercept. That's our first goal. Tomorrow we'll look at solving problems, but today was to find the x and y-intercepts. When we said the x-intercept is where the line crosses the x-axis and the y-intercept where it crosses the y-axis. We looked at negative slope and we have positive slope. And here you have no slope, a horizontal line. We looked at the steps using your graphing calculator and how to find the x and y-intercepts. And the steps are on page 25, but it's also in your calculating instruction applied math handout, finding the y-intercept, finding the x-intercept. Okay. Actually, this is not finding the x-intercept, this is finding the y-intercept. Sorry, there we go. Okay, take that back what I told you here. This is a step to finding the y-intercept. And this is a step to determine the x-intercept. Sorry about that, my error. Okay, I was jumping the gun here. So this is finding the x-intercept. And over here is finding the y-intercept. Now this is finding the y value. It's also giving the same thing, but it's a little bit more complicated way. It's much a longer way of doing it. I'll remove this. You could find it using this procedure here, but it's much simpler to find the y-intercept using these steps here and find the x-intercept using the steps here. And also it's on this page on your calculator. Okay. We also looked at how to find x and y-intercept using Desmos. Your task for tomorrow is to look at example 3, which we've completed, finding their x and y-intercepts. An example for A and B, and use the algebraic method to find your x and y-intercept. You want to try it. And for practice assignment, I want you to try questions 1 and question 2 for now. Tomorrow I'll go through problems questions. You can attempt these, but they're a little different, but I want you to try the x and y-intercept. So questions 1 and 2. Tomorrow, or the next lesson, we are going to look at problem solving, finding x and y-intercepts. So for tomorrow's lesson, we'll be looking at to solve problems involving x and y intercepts and recognize limitations of the x values and y values. So we've completed this today.